Hello, this is 25th day of the 30 days of code challenge. The name of the challenge is running time and complexity. So let's understand this problem. This is the definition of the prime number. The prime number has no positive divisors other than man and itself. Okay, we know that. And we have t-test cases, and in each test case we have given n, and we are going to check the primality, if the number is prime or not prime. So there's a note here. If it's possible, try to come up with the square root of n complexity algorithm, it says. So we are going to solve this problem in a square root of n complexity. Just let me explain the solution, okay? Let me open the Paint. Okay, let's say we have given 45. The 45 is a number that's between 6 squared and 7 squared. 6 squared is 36, 7 squared is 49. So it's approximately is 6.7 maybe. Let's say our square root of 45 is 6.7 squared. Let's say this. Let's just assume this, okay? So in a prime number, we shouldn't consider 1 and itself. So we are going to get rid of this 2, okay? So let's do factorization on 45. By saying factorization, I mean integer factorization. 45 is a multiple of 3 and 15, and 45 is a multiple of 5 and 9, and it's also a multiple of 9 and 5, and lastly it's a multiple of 15 and 3. So okay, if we take a look into the factorization table here and here, we can see the pattern. The pattern is the second number in the factorization always decreases, and first number always increases. And if we take a look here, if we split this factorization into 2, we can see there is some kind of pattern that repeats. So these 2 expressions are same, just there's a swap between 2 numbers, and these 2 expressions are same, there's also a swap between 2 numbers. So we can conclude this as like if our first divisor is bigger than square root of that of the number, then the second divisor of the number is less than the square root of the number. So we can see first divisor is less than 6.7. Second divisor is bigger than 6.7. Yeah. In the second expression, first divisor is less than 6.7, and the second divisor of the 45 is bigger than 6.7. But in the third expression, the pattern swaps. So the first divisor is bigger, the second divisor is less than the square root of 45. So we can say we don't need to look to the second part of the table because it repeats. So we are not going to look this part. We can erase the two last expressions. So if we look to the first two expression, we can see if we check the numbers to the square root of n, we can solve this problem. And the complexity of the checking the primality will be square root of n. So we will come up with this complexity square root of n. It will be really great because they are just the problem suggests the square root of n complexity, so it's not mandatory, but we are doing this in a square root of n complexity. Okay, so let's take a t and input. Okay, for I in range 0 to t, we are going to take n and input. Okay, so we are going to say, okay, check this n, the is prime function will check this n if it is prime or not prime. Okay, so def is prime. Okay, okay. N can be between 1 and 2 multiplied by 10 to 9. So the 1 is really a problematic number because it's not prime number. So just let's say if n is 1, then return not prime. So dealing with 1 is a good option because it's a little bit problematic. Okay, so if we are returning string, we should print that. Okay, sorry. Okay, then how do we get the square root of n in Python? We will use math sqrt function. So we need to put math. Let's sqrtn is math.sqrtn. Okay, here we are getting square root of n. So for I in range, go from 2 to square root of n plus 1 because range function is not inclusive. It doesn't include the right boundary. So we are adding 1 to the right boundary. Okay. If n mod I is 0, if I is a divisor of the n, then return not prime. It shouldn't have a prime between 2 and square root of that number, so not prime. Okay. If those numbers are not divisor of the n, then this is a prime number. Okay, let's run this code. Something wrong with okay. Okay, we have something else wired here. Okay, it gives runtime error. Okay. Then this can be a float, so we should convert this to the integer. Run code. Okay, sample test cases are passed. Submit this code. Right. We have solved this problem. Thank you for watching this video. See you in the next video. Bye.